Hello everybody, today I'm going to talk about building a home theater PC, custom build it with pretty nice parts. So let's talk about the requirements. It has to be compact because it is going to fit in like a home theater system setup, so it has to be the same size as other boxes like the DVD player or other devices, so it has to be pretty small. So that rules out the standard ATX board, which is pretty big in comparison, and also the micro ATX too. So I selected the mini-itx form factor, which is 170 by 170 millimeters, or 6 by 7 inches squared. So that's this board right here. It's pretty small. It's still got the external RAM slots and different peripherals that you'd need for a home theater setup, versus these other boards which have less and less features on them as it gets smaller, and also they're also less powerful too. So I was debated whether or not I wanted an external power supply or an external brick for it. I went with external brick because it would reduce the size even more than before, and with a so small of motherboard you don't need very much power on it. I think the motherboard I have is about 20 watts, so one of these would be definitely overkill. These supply like 250 watts, so it's kind of way more power than you actually need, and it also reduces the case size by quite a bit. Another requirement, it has to be low cost. You don't really need much hardware to run a home theater setup, so keeping the cost low is always good. So I'm going to use used and found parts. Found parts are in the parts that are inside my tool chest or junk bin over here. Someone running through the dumpster looking for parts. And I'm going to use the slightly older hardware just because it's a little bit less expensive than the brand new stuff, and if you don't need much power then you might as well use older hardware. And the last requirement is it has to be energy efficient. I want to keep it under 50 watts just so the heat dissipation inside the cabinet doesn't get too high and start overheating parts or burning out something. So the motherboard selected is the ECS BAT-i2 /J1900 V1.0, and this is a mini-itx board. It has HDMI out. So it's perfect for a home theater setup, and it's got a nice quad-core 2 GHz CPU, Intel Celeron, which is pretty good, and it's surprisingly a 10 watt TDP, which is pretty low power. This is I think this motherboard is from 2014, so it's a little older. The newer ones are about 6 or 7 watts TDP, so it's not much of a difference. The big thing about it is that it has SATA inputs, so I can use solid state drives and also an external hard drive if I want to, or a storage drive. And also has a 19 volt input power right here, which is very helpful for reducing the size of the case I need. It's got a RAM slot on it, so I can stick in a nice high capacity memory module in there. This is external SATA power, so everything's coming from this motherboard. I don't need to supply 5 volts or 12 volts to the SATA hard drives. It all comes from the board, which is pretty nice. And then there's the 2 SATA power plugs right there. It also has a mini PCI slot right here, which is good for like wireless modules or whatever, etc. you want right there. This board doesn't support mSATA, so you couldn't put a hard drive right there. I investigated that, but it didn't support it, unfortunately. And there's also miscellaneous other things that are pretty cool about this board. Also, the case which I selected is the Minibox M350. It's a mini-itx case. It's really small. You can see by the size right there. It has a nice little USB port on the front, which we can plug in like a IR module or a RF module to the front of it, so you get remote access from like a remote or a keyboard or something. That's pretty nice. So you don't have it in the back, you can get better signal range in the front of it. It comes with a lot of different other features which are pretty cool too, like you can put it on a DIN rail, so for like embedded applications, and pretty nice. And here's all their miscellaneous parts which I've selected. I've selected an 8 GB stick of RAM, which is the maximum this motherboard supports. You might as well go with the maximum because there wasn't much difference in price between 4 GB and 8 GB, so I might as well just get 8 GB total. And I had a little bit of problem with the RAM with this motherboard. It had to match what the manufacturer specified on the website or else it wouldn't work. So that's just a warning if you want to get the motherboard. I always go with the RAM on the website with this motherboard because I had another stick which didn't work, and it was the same. It had the same specs and everything, but it just didn't support it. The hard drive I found in my junk bin. It's a 60 GB OCZ solid state drive. Not much more to say about that. I had it in my junk bin, so I used it. This home theater PC is mostly going to be used for streaming, so I don't really need to have a high capacity storage drive to store movies or anything. So I might add it in the future though, if needed. I got a female to female power cable for the SATA drives. The motherboard has a male output, so the female fits into it, and also it plugs in the hard drive right there. So it's a little bit hard to find these cables on the internet. You have to do a little searching because they're not standard at all. And this regular SATA cable, which I found in a junk bin, my junk bin. And I bought a small fan. The case doesn't require a small fan for motherboards with the 10 watt TDP, but I might as well just throw it in there, just whatever, just so it doesn't overheat. And I also got an extra hard drive disk mounting bracket, just so I can expand this in the future if I want more hard drives. And this is a price list of everything costed. And it's $164, which is a little bit more than what I wanted to put into this project. But I've also found the hard drive disk, so that reduces it, and also found the SATA cable too, so a little bit less than $150. So why would I use an x86 PC instead of a Raspberry Pi? If I remember what I read online, the Raspberry Pi can be a little sluggish with home theater PC setups. With the software I'm using, which we'll get to a little bit later. And the Raspberry Pi 3 might work, but it's still pretty new and there's not much software supporting it right now for home theater PC. The bigger thing is that the motherboard has a SATA input, so I can use my solid state drive, which I had already. Wouldn't need to buy a fancy SD card or anything for the Raspberry Pi, so that's great. And the SATA has way more, it's got way more throughput than a SD card, so that's another plus. The motherboard that I selected also has a much more powerful CPU, and it's got a lot more RAM than the Raspberry Pi. And I can also do a future 2 TB expansion on my motherboard, which I can't do with a Raspberry Pi unless I network it, and that's another whole thing. So it's just simpler to use the x86 PC in my application instead of the Raspberry Pi. What's advantages about the Raspberry Pi is that it's got much lower power consumption to it. I guess it's more mobile too. Okay, I got my parts right here. So this is the ECS motherboard right here. You can see the CPU is right there. The RAM I've already got installed. There's nice DC-DC converters right in that section. Just pretty good. You got the SATA slots, and here's the back panel. Got the DC input jack. It's got the PS2 legacy mouse connectors and keyboard. USB 3.0 port, 4 USB 2.0 ports, Ethernet port, which is a gigabit, a VGA monitor, just like a screw hole right there, and basic audio. But the audio over the HDMI works good. The HDMI is down there, by the way. That's that. Here's the case. See if we can pop it open quick. It's got a little fan slot in the inside right there. It's got the front panel connectors, and they go back to the motherboard. There's a connector for, I think it's an antenna or something like that, or a DC jack right there. And then the back panel from the motherboard goes right there. And there it goes. So it comes out just a little bit, and then it springs off the top. It's kind of nice inside. It's nice black, spray painted. And I think I'm going to remove this just for now to get the motherboard in. Throw that in there. Go another way. There we go. Perfect. Oh yeah, this motherboard also has like a LVDS connector, which you can use for hooking up a monitor directly to it. That's kind of nice. Just for kind of cool. Haven't seen that in a motherboard before, so real unique. This motherboard didn't come with the back panel, so it's kind of bare right here right now. So I mean, that's fine. It's gonna be the back of the unit. So there's a fan that's supposed to be ultra silent. I think I will put it in the front of the case, just so it blows across the motherboard. See how to get this front panel off. Now here's that USB port that I've talked to you about. It's got USB ports in the front, so you can get a remote signal in there. 2 power LEDs, auto start, disable button, jumpers in the front. So this is the USB, which plugs in over here. Pretty simple. Gotta line up the things. There we go. That's easy. Let's get the fan in. Surprisingly, there's no case marking on the side that tells you which way the fan blows. To look it up quick. Forgot. The fan blows from this way out, so it blows out that way. So I'm going to put it like this, so it blows into the case. The cold air blows into the case like that. And the connector is pretty close by. It's pretty close, but I think it'll still work. And let's just plug it in to the closest power. Let's put it on the CPU fan. There we go. Cable hides under there pretty good. No worries about that. And you got these power switches right here, which are nicely labeled. So one's for power LED and one's for power switch. So there is no reset button on this computer. It's only a power switch. Okay, I got the user manual now, and I found the page that has the front panel header on it. So we've got the power LED right here, which is the fourth slot to the third slot, and the power switch is the first and second slot right there. So that's pretty easy. You just hook it in This is a power switch right now, which just goes in this first two ones right here, and the power LED goes right there. And I think I just put a little zip tie in there, make it look nice. I'll just put this one right here. I have a spare just so I can expand in the future. Alright, now the hard drive will go on this thing. And we want, let's put this cable in first, I guess. And this is a 90-degree bend on it. This is a female to female SATA cable. Good for power. It fits right there. Wonder if I should use a 90-degree angle on that one. One on there. There we go. Fits in there fine. And put it right here or right there. I think it's gonna be better if it's over here. Put this above the USB cable. Let's try that. Now it looks like it's all together now. I'm going to put this is the wireless mouse and keyboard right in here. So I can get it plugged in the USB port. I got my 19-volt power strip here. And just plug it in, see if it works. Alright. Looks like the fan is spinning up. And it's blowing the right way. I can hear the fan, but it's still pretty quiet, so that's good. I'm going to swap over that hard drive, I guess, just so it blows over the fan. Looks like it's all together now. It's a pretty small build. And now let's get the software set up and ready to install on the computer. Now into the software. I installed Kodi onto the home theater PC. I also wanted to install Netflix too, but the Kodi software, the third-party libraries didn't really work very well, so I just went with Google Chrome to play Netflix. So I originally wanted to install OpenELEC, which stands for Embedded Linux Entertainment Center. That didn't work out because I couldn't install Chrome because it was such a stripped-down operating system. It didn't have enough juice to run Chrome on it. I don't think I could get like a terminal going to be able to install anything. Then I looked at Kodi Ubuntu, which had it was a little bit outdated, so I went on to Ubuntu plus Kodi on Linux Mint KDE 18 and Kubuntu, each running the 16.04 Ubuntu version. Also, I ran Linux Mint Mate 18 too on 16.04, but all three of those had like a freezing issue. The OS would totally lock up, the numlock key wouldn't work, so it'd be like a total freeze. So that was really bad. And then I looked at the logs, and it said perf error, which could stand that the firmware on the CPU is outdated, and it causes the OS to lock up. I think it was called like the microcode, but that didn't help anything. Then I upgraded the kernel to the most recent version, and that didn't seem to work at all either. It would still lock up after a few hours. But then I installed Linux Mint KDE 17.3, which uses the 14.04 Linux Ubuntu version, and that worked perfectly. I ran it for like 24 hours and it didn't lock up using a video test. So that seemed to work pretty good. I just used Google Chrome to play Netflix because the Netflix XMBC third-party plugin, or also Kodi, Flix to Kodi, didn't work. There was an error saying that said just see the log for error details. When I looked at the log, it's just said connection error, so that didn't really work very well. I think it was because I logged in too much times and then Netflix wouldn't let me log in anymore. But any error like that is just really annoying. It's intermittent. So I actually went back to Chrome and I used a Netflix app on Chrome, and also like a YouTube app, so I can just click if I want Netflix or YouTube on Chrome. So that worked pretty good. I'm still going to install Kodi on the system, only just for like for the nice user interface. But whenever we want to watch Netflix, I'm just going to go on Google Chrome and use that. But I got it working with Linux Mint KDE 17.3, and it's been working really great since. So overall, this project was a success. I had a few problems with the software, but I got it solved by trying different Linux versions. So I hope you found this interesting, and I'll see you next video.